A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
So, Herman, I have a theory. I think the team at DeepSeek just decided to go on a very long, very quiet vacation after their big moment last year. They just ghosted the entire AI industry, left us on read for about 12 months, and waited for everyone to stop talking about them before kicking the front door down again. It was like they were the main character in a movie who disappears into the mountains to train in a montage, only to reappear when everyone thought they were a one-hit wonder.
It certainly felt that way if you were only watching the headlines, Korn. But if you were looking at the preprint servers and the specialized hiring boards in Hangzhou, you could see the pressure cooker was starting to whistle. I am Herman Poppleberry, by the way, for anyone joining us for the first time, and I have been refreshing the DeepSeek GitHub page more than is probably healthy for a donkey of my age. My ears have been twitching for months waiting for this drop.
It is definitely not healthy, Herman, but I appreciate the sacrifice you make for the listeners. Today's prompt from Daniel is about this massive comeback. He is asking us to dig into the DeepSeek V4 and R2 launch, the whole Hunter Alpha mystery from a few weeks ago, and whether these guys are actually going to bankrupt the rest of the industry with their pricing. We are talking about a company that everyone claimed had faded into obscurity, only for them to drop a nuke on the pricing charts.
It is the perfect time to talk about it because we are finally seeing the full picture of their new architecture. People were calling the 2025 launch of V3 a Sputnik moment, but V4, which just dropped earlier this month to coincide with the 2 sessions in Beijing, feels more like they are trying to build a permanent moon base. We are looking at a 1 trillion parameter model that somehow runs with the agility of something a fraction of that size. It is a massive statement of intent, timed perfectly with China's major political meetings to show off their domestic technological prowess.
1 trillion parameters. That sounds like one of those numbers people just throw out when they want to sound impressive, like saying you have 1 billion cousins or you can eat 1,000 leaves in a minute. Is there actually a functional reason for that scale, or is this just architectural flexing to make the Silicon Valley labs nervous?
It is a bit of both, but mostly functional. The key is their mixture of experts approach, which they have refined to an incredible degree. Even though the total parameter count is 1 trillion, the model only activates 32 billion parameters per token during inference. That is the secret sauce. It allows them to have this massive deep well of knowledge and nuance to draw from without the massive compute cost of a dense model like GPT 5.4. Think of it like a library with 1 trillion books, but you only ever have 32 librarians running to fetch exactly what you need for a specific sentence. It is efficient, but the sheer size of the library means those librarians have access to everything.
Okay, but we have seen mixture of experts before. Mistral does it, Grok does it. What makes V4 different from just a bigger version of what they were doing last year? Because if it is just more of the same, I am not sure it justifies the hype of 1 trillion parameters.
The real breakthrough is something called Manifold-Constrained Hyperconnections, or MHC. Liang Wenfeng and his team published the foundational paper on this back in January 2026, and it is honestly brilliant. In traditional deep scaling, you run into massive training instability once you cross certain thresholds. The gradients just start doing weird things, the model starts to collapse, or it just stops learning. MHC essentially uses geometric constraints to keep the model's internal representations from drifting into areas of the latent space that cause those hallucinations or crashes. It is like putting high-tech guardrails on a Formula One car so it can go 300 miles per hour without shaking itself to pieces. It allows them to scale to that trillion parameter mark while keeping the training process smooth and the output stable.
I like the guardrail idea, mostly because I am a sloth, and speed generally terrifies me. If I am going fast, I want to know I am not going to fly off the track. But let's talk about the context window for a second. Daniel mentioned a 1 million token window for V4. We have seen that from Gemini for a while now. So is DeepSeek just playing catch-up there, or is there a twist that makes this special?
The twist is the retrieval accuracy over that million tokens. Usually, when you cram a million tokens into a model, the middle of the document becomes a bit of a blur. It is the classic needle in a haystack problem where the model remembers the beginning and the end, but forgets the middle. But with the MHC architecture, DeepSeek v4 is hitting 99% retrieval accuracy across the entire window. And they are doing it with native multimodality. This is not a text model with a vision encoder slapped on the front like a Frankenstein monster. It is processing text, images, and video in the same underlying latent space from day one. It understands the relationship between a frame of video and a line of code natively.
That brings us to the Hunter Alpha situation. For a few days there in mid-March, the internet was convinced DeepSeek had leaked their crown jewels. This mystery model shows up on OpenRouter, starts absolutely destroying benchmarks, and everyone points at Hangzhou. The speculation was wild, Herman. People were saying it was a rogue employee or a state-sponsored leak. Then, on March 19th, Xiaomi comes out and says, "Actually, that is us. That is our Mimo V2 Pro."
That was such a fascinating moment for the ecosystem. It proved that DeepSeek's real contribution isn't just their own models, but the training recipes they have pioneered. Xiaomi essentially took the DeepSeek v3.2 architecture and the reasoning techniques from the R series and applied them to their own proprietary datasets. It shows that DeepSeek has become the reference architecture for the entire Chinese tech sector. They are the national champion now, whether they officially want that title or not. It is like they wrote the textbook that everyone else is now using to build their own specialized models.
It is a bit of a double-edged sword, right? Being the national champion means you get the best engineers and the state-backed hardware, but it also means everyone is looking at your server routing with a magnifying glass. I saw some reports that almost all DeepSeek API traffic is still hitting mainland China servers, which makes a lot of enterprise legal teams very nervous. If you are a big bank in London or a tech firm in San Francisco, that is a hard sell.
That is the big hurdle for them in the West. Even if the model is 40 times cheaper, if your data privacy officer sees a route to a server in Hangzhou, they're going to pull the emergency brake. But from a purely technical standpoint, what they are doing with non-NVIDIA hardware is incredible. They are optimizing specifically for Huawei and Cambricon chips. While the rest of the world is fighting over H100s and Blackwell chips, DeepSeek is proving you can get world-class performance out of domestic Chinese silicon through sheer algorithmic efficiency. They are building for the hardware they have, not the hardware they wish they had, and that constraint is actually making their software better.
Speaking of efficiency, let's talk about the price. This is the part that usually makes my ears perk up, even if I am moving slowly. 27 cents per million input tokens. Herman, GPT 5.4 is still hovering around $10 for that same million tokens. How is that even possible? Are they just subsidizing this to kill the competition, or is the tech actually that much cheaper to run? Because that is not just a discount. That is a different universe of pricing.
It is mostly the tech, though there is certainly a strategic element. When you only activate 32 billion parameters per token, your compute cost per generation is drastically lower than a dense model. Plus, their KV cache compression is leagues ahead of the industry. They have found ways to store the model's memory of a conversation using a fraction of the VRAM that OpenAI or Anthropic requires. So while there might be some strategic pricing involved to gain market share, the underlying math actually supports a much lower cost. They aren't just burning money, they are just running a much leaner engine. It is the difference between a massive V12 engine that gulps fuel and a high-tech electric motor.
It makes me wonder why anyone would use the big, expensive models for anything other than the absolute highest tier reasoning tasks. If I am building a startup and I can get 90% of the performance for 1/40th of the cost, my CFO is going to make that decision for me before I even finish my coffee. It changes the unit economics of AI entirely.
That is exactly what we are seeing in the startup space right now. DeepSeek v3.2, which came out late last year, has become the workhorse for agentic workflows. They call it thinking in tool use. Instead of the model just talking to you, it is designed to pause, reason about which tool to use, and then execute a multi-step task autonomously. It is less of a chatbot and more of a digital employee. And that leads us directly into the new R2 model, which takes that reasoning to the next level.
Right, the R2. This is the one that is supposed to go toe-to-toe with the OpenAI O series, the ones that sit there and think for 30 seconds before answering. What is the deal with internalized reasoning? Is it just a fancy way of saying the model talks to itself in a hidden scratch pad? Or is there something more profound happening under the hood?
It goes deeper than a scratch pad. In R1, you could see the chain of thought. It was very explicit and sometimes quite long-winded. In R2, they have moved toward what they call internalized reasoning. The model has been trained through reinforcement learning to compress those reasoning steps into its internal activations. It is still doing the hard work of logic and verification, but it is doing it more efficiently and with fewer tokens wasted on the output. It is scoring around 72% on the ARC-AGI2 benchmark. Now, Gemini 3.1 Pro is still the king there at 77%, but R2 is closing that gap fast, and it does not have the same latency lag that the earlier reasoning models had. It feels snappier.
I have noticed that R2 feels much more like a conversation, and less like I am waiting for a slow computer to boot up. But let's pivot to the agent stuff. Daniel mentioned they are hiring a ton of agent infrastructure engineers for something called OpenClaw. That sounds like a name a supervillain would give their secret base, or maybe a very aggressive arcade game.
It does sound a bit menacing, doesn't it? But OpenClaw is actually their attempt to standardize how AI agents interact with software environments. Right now, every agent has its own way of clicking buttons or writing code, and it is a mess of different protocols. DeepSeek is trying to build the underlying rails for autonomous systems. They want to move beyond the chatbot. They want their models to be the brains inside of autonomous dev tools, research assistants, and even physical robotics. That is why the Xiaomi connection is so important. Imagine DeepSeek R2 running the logic for a Xiaomi humanoid robot. That is the long-term play here. They are building the brain for the machines.
So they aren't just building a smarter box to talk to. They're building an operating system for things that actually do stuff in the real world. That explains the shift in their research direction. It is less about making the model a better poet and more about making it a better engineer. They want it to be able to handle a wrench, or at least a digital version of one.
Precisely. If you look at their recent job postings, they aren't just looking for LLM researchers anymore. They are looking for people who understand system architecture, low latency networking, and hardware-software co-design. They are becoming a vertically integrated AI company. They build the training algorithms, they optimize for the specific chips like the Cambricon ones, and they build the agentic framework that sits on top of it all. It is a full-stack approach that is very different from the labs that just focus on the model weights.
It makes the fade to obscurity narrative look pretty silly in retrospect. They weren't losing steam, they were just retooling the entire factory. It is a very different vibe from the Silicon Valley approach, where you have to have a new product announcement every Tuesday, or people think you are dying. They were willing to be quiet for a year to get the architecture right.
It is a very disciplined approach. Liang Wenfeng has a background in high-frequency trading and quantitative systems, and you can see that DNA in DeepSeek. Everything is about optimization, latency, and cost per unit of intelligence. They treat AI like a commodity that needs to be produced as cheaply and reliably as possible. They aren't trying to build a god, they are trying to build a utility.
Which is great for us as users, but I do want to go back to the privacy concern for a second. If I am a developer in the US or Europe, and I want to use V4 because it is cheap and brilliant, what are my actual options for keeping my data from making a round trip to Hangzhou? Can I run this locally, or am I stuck with the API?
That is the big advantage of their open weight policy. Unlike GPT-5 or Gemini, DeepSeek releases the weights for their models. Now, running a 1 trillion parameter model locally is a tall order for most people. Even the V4 Lite version, which is 200 billion parameters, requires a pretty beefy setup. But for a mid-sized company, you can host these on your own private cloud instances. You can put them on a cluster of A100s or H100s in your own data center, and then the data never leaves your building. That is why they are winning the developer heart and mind war. They give you the keys to the kingdom, whereas the other labs just let you look through the window.
That is a huge differentiator. It turns it from a service you rent into a tool you own. I think that is a distinction that gets lost in the noise sometimes. When you are using a closed API, you are at the mercy of their uptime, their pricing changes, and their censorship filters. If you have the weights, you are the boss. You can fine-tune it, you can quantize it, you can do whatever you want.
And they are leaning into that. They have even been providing specialized quantization scripts to help people run these models on consumer-grade hardware. They want DeepSeek to be everywhere. They want it to be the default engine for the next generation of software. They are betting that by being the most accessible, they will become the most essential.
Okay, let's get practical for a minute. If someone is listening to this and they are managing a dev team or they are a CTO, how should they be evaluating DeepSeek v4 versus the incumbents right now? Is it a binary choice, or is there a way to play both sides without getting caught in the middle?
I think the smart move right now is a hybrid approach. You use something like Gemini 3.1 Pro or GPT 5.4 for your most sensitive, high-stakes reasoning where you need that extra 5% of accuracy and the legal peace of mind of a US-based provider. But for everything else, your internal documentation bots, your code completion, your data extraction, your agentic workflows, you switch to DeepSeek. The cost savings alone will fund your entire R&D budget for the next year. It is about being pragmatic.
It is like having a fleet of reliable work trucks and one or two Ferraris. You don't use the Ferrari to haul gravel, and you don't use the work truck to go to a gala. But most of life is hauling gravel.
That is a rare analogy from you, Korn, but it fits perfectly. You don't need a $10 per million token model to summarize a meeting transcript or format a JSON object. DeepSeek v4 is the work truck that happens to have a jet engine inside. It is overpowered for the price, and that is exactly what developers want.
I will take the jet-powered truck, please. But what about the technical benchmarks? Daniel mentioned DeepSeek Coda v3 and DeepSeek Math v2. Are they still leading the pack there? Or have the specialized models from other labs caught up while DeepSeek was in their quiet phase?
In coding and math, they are still incredibly hard to beat. DeepSeek Coder v3 is currently the top-performing open-weight model for Python and C++. In some benchmarks, it is actually outperforming the flagship closed models. The reason is that they have a very specific way of data curation. They don't just scrape the web. They use synthetic data generation to create complex logical problems that the model has to solve during training. It is like they are teaching the model how to think through a problem rather than just memorizing the answer. They are building a logical foundation, not just a pattern matcher.
It sounds like the era of just throwing more data at a model is officially over, and we are now in the era of high-quality, curated, and synthetic reasoning data, which is probably good for the internet, because we were running out of human-written text anyway. We have already eaten all the books and all the blogs.
We definitely were. The next frontier is going to be video and physical interaction data. That is why the native multimodality in v4 is so important. By training on video, the model starts to understand the physics of the real world, how objects move, how cause and effect work in a three-dimensional space. That is what will take agents from being just software bots to being something that can actually operate in the physical world. It is about grounding the intelligence in reality.
That is a bit of a wait, what? Moment for me. Are you saying v4 actually understands that if I drop a glass it breaks? Like, it has a concept of gravity and impact?
In a way, yes. By processing millions of hours of video, it builds a world model that is much more sophisticated than a text-only model. It understands temporal consistency. If you ask it to describe what happens next in a video clip, its predictions are grounded in the laws of physics that it has observed. It is not just predicting the next word, it is predicting the next state of the world. It is a subtle but massive shift in how these models represent information.
That is both incredibly cool and slightly terrifying. It brings us back to the R2 reasoning. If you combine a world model with that kind of internalized logic, you are getting very close to something that looks like actual intelligence, not just a very fancy autocomplete. It is starting to feel like we are building something that can actually reason about the world it lives in.
We are definitely crossing that threshold. And the fact that DeepSeek is doing this while maintaining their commitment to open weights is what makes this moment so pivotal. They are effectively commoditizing high-level intelligence. They are making it so cheap and so accessible that the bottleneck is no longer the AI itself, but our ability to build the systems around it. The challenge now is on the developers to use this power effectively.
So the takeaway for everyone listening is, don't ignore the quiet ones. DeepSeek took a year off from the spotlight to rebuild their entire stack, and they came back with a trillion-parameter multimodal beast that costs next to nothing to run. They proved that a year of R&D can be more powerful than a year of marketing.
And keep a very close eye on OpenClaw and their agent infrastructure. That is the real battlefield for the rest of 2026. It is not about who has the best chatbot anymore, it is about who has the most capable autonomous agents. DeepSeek is betting the farm on being the foundation for those agents, and with their current pricing and performance, it is a very strong bet.
I think I need to go lie down and process the idea of a jet-powered work truck that understands physics. That was a lot, even for me. My sloth brain is spinning.
It is a lot for anyone, but it is a very exciting time to be watching this space. The pace of innovation isn't slowing down, it is just moving into the foundations. We are seeing the infrastructure of the future being built right now.
Well, if you want to dig deeper into how we got here, you should definitely check out episode 1471, which we called the Cursor Incident. It covers that first big wave of Chinese AI models taking over Western developer tools. And if you're curious about that Xiaomi connection Herman mentioned, episode 1599 goes deep on the MIMO V2 and the rise of physical AI agents.
Both are great context for what is happening right now. It is all connected, from the code editors to the robots on the factory floor.
Thanks as always to our producer, Hilbert Flumingtop, for keeping the show running smoothly while I move at my usual pace. And a big thanks to Modal for providing the GPU credits that power this show. It is great to have a partner that understands the importance of high-performance infrastructure.
We couldn't do it without them.
This has been My Weird Prompts. If you found this useful, or if you just want to make sure you don't miss the next big architectural shift, find us at myweirdprompts.com. You can find our RSS feed there and all the different ways to subscribe.
See you next time.
Catch you later.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow to